As NASA's James Webb Telescope turns its gaze on a selection of the more than 5,000 strange new worlds that have been verified to exist in our galaxy, researchers will start to piece together a more complete picture of their lives from birth to death. Exoplanets, or planets outside of our solar system, have a wide range of sizes and characteristics according to research so far. Webb will probably put to rest decades-long arguments about how planets form and die, thanks to its capacity to use infrared light to reveal formerly unexplored details of the universe. From 1,000,000 miles away, the observatory will measure the composition of exoplanet atmospheres and probe their structure in 3 dimensions. And it could help us understand planets like our own, small, rocky, possibly habitable worlds, and what it takes to create them. Join us today as we discuss the 2 new super-Earths that NASA's James Webb Space Telescope will study. The James Webb Space Telescope is now at its destination, which is about 1,000,000 miles distant from Earth and 4 times farther away than the Moon. It is the most expensive and intricate space telescope ever built, costing $10 billion. It spent much of January 2022 unfolding its mirrors and components in order to come into position to show us the early universe. The telescope is expected to change astronomy as we know it, and the excitement around it is almost palpable. There's a whole generation of astronomers who have been waiting for the Webb telescope. Some say it has the potential to open up whole new fields of science. But how exactly will it do that? How will the Webb telescope change astronomy and cosmology? What might it reveal about our universe and its history? We think the excitement has derived from being the successor to Hubble, and people have gotten used to lovely Hubble pictures, great discoveries from Hubble. And the whole structure of the Webb Telescope project is to go beyond Hubble, but to continue the excitement and even increase it, because we're opening up a new part of the electromagnetic spectrum. That is, opening up a new part of the set of wavelengths that light can have to study. And we're doing it with a telescope bigger than Hubble, and that works at much, much longer wavelengths. And so we're going to be seeing quite a new view of the universe that will tell us many, many new things, including some we probably aren't guessing right now. The things that we can't even imagine maybe just yet. Many people imagining a telescope might be thinking one of those giant telescopes sitting in an observatory on a mountaintop somewhere. But this is a space telescope, the Webb, just to remind you. Why is it advantageous to, and really why would you go to the bother of putting a telescope in outer space? Well, researchers and scientists go to the bother of putting a telescope in outer space because those on Earth must look through the Earth's atmosphere, which limits what they can accomplish. In the case of Webb, astronomers aim to view infrared wavelengths, which necessitates cooling the telescope. And if you tried to cool a telescope on a mountaintop on Earth sufficiently to observe these dim, weak, distant things, the atmosphere, water, and so on would freeze out, rendering the telescope useless. So you must travel to the vacuum of space. This allows the scientists to cool the telescope while also removing any atmospheric absorption. Astronomers have a fundamental question. How do planets form? Webb will explore the disk of gas and dust spinning around young stars using one of its most sensitive equipment, the Mid-Infrared Instrument, MIRI. According to Charles Beichmann, Executive Director of the NASA Exoplanet Space Institute at Caltech, and a key member in multiple Webb observation missions, scientists want to know why these disks appear to have rings and gaps. Are planets in the process of formation opening these gaps, he wonders. Beichmann and his colleagues will also look for dusty remnants of planet formation in other systems to see if they resemble our own Kuiper belt, swarms of would-be comets in our outer solar system, or the asteroid belt between Mars and Jupiter. A number of studies will focus on young, hot planets that are still cooling and contracting after formation. The scientific team will collect spectroscopic measurements using the MIRI instrument and Webb's Near-Infrared Spectrograph, NIR-SPEC, splitting light from the planets into a spectrum, producing a form of fingerprint of molecules in these planets' atmospheres. This should disclose properties such as chemistry and the presence of clouds, as well as important clues about how these massive planets formed. Astronomers also use Webb's high-precision spectrographs on 2 intriguing rocky exoplanets. Imagine how much closer to the Sun Earth would be. So near that a year would only last a few hours, so close that gravity has forced one hemisphere into unending scorching daylight while keeping the other in perpetual darkness. So near that rocks start to melt, the oceans boil, and lava starts to fall from the clouds. While there aren't any planets like this in our solar system, the Milky Way galaxy is home to many rocky, about Earth-sized, incredibly hot planets that are near to their stars. What actually do these planets' atmospheres and surfaces look like? The James Webb Space Telescope of NASA is about to offer some answers. Included in the investigations planned for the first year are studies of 2 hot exoplanets categorized as super-Earths due to their size and rocky composition: the lava-covered 55 Cancri E and the airless LHS 3844b. Scientists will use these planets to train Webb's high-precision spectrographs in order to better grasp the geologic diversity of planets throughout the galaxy. Both planets are super-Earths, although they are quite different from one another. This makes them perfect Webb targets. Scientists seek to learn more about their similarities and differences, as well as how they evolved. 55 Cancri E, Lava World. First 55 Cancri E. It was discovered in 2004 and orbits a Sun-like star 41 light-years away. It has around 8 times the mass of Earth and 1.9 times the radius of Earth. The planet orbits its star relatively near, completing an orbit in less than 0.7 days, or less than 18 hours. It's a burning world due to its proximity to its star, so scorching in fact that its temperatures are sufficient to melt rock. Scientists believe the average temperature is around 4,400 degrees Fahrenheit, 2,400 degrees Celsius. As a result, astronomers believe that the planet's day side is likely covered with lava. We say day side because 55 Cancri E is assumed to be tidally locked, with the same side always facing its star. This is analogous to the Moon being tidally locked to Earth. Normally, the region of a tidally locked planet closest to its star should be the hottest. However, on 55 Cancri E, the hottest zone appears to be offset slightly from that location on the planet. That observation was made by NASA's Spitzer Space Telescope. Scientists aren't sure why this happens, but they have theories. A dense atmosphere capable of moving heat around is one possibility. Astronomers will use Webb to study the thermal emission spectrum of the day side of the planet. They will do so using the Near-Infrared Camera, NIRCam, and Mid-Infrared Instrument, MIRI. Hughes said, "If it has an atmosphere, Webb has the sensitivity and wavelength range to detect it and determine what it is made of." However, there is still a chance that 55 Cancri E is not tidally locked. If that is the case, then it might rotate 3 times for every 2 orbits, called a 3-2 resonance. This seems to be similar to the planet Mercury. If so, the planet would have a day-night cycle similar to Earth's and that of the majority of the other planets in our solar system. Alexis Brandeker at Stockholm University said, "That could explain why the hottest part of the planet is shifted. Just like on Earth, it would take time for the surface to heat up. The hottest time of the day would be in the afternoon, not right at noon." Using Webb, Brandeker and his team can put this hypothesis to the test. The heat emitted from the illuminated side of 55 Cancri E will be measured using NIRCam throughout 4 distinct orbits. If this is true, 55 Cancri E may have a somewhat unusual hydrological cycle in which the surface rock gets hot and melts during the day. It could even vaporize, producing a thin atmosphere. The vapor would cool down in the evening, forming rain composed of droplets of lava. Those droplets would solidify again at night. LHS 3844b, a hot, airless world. While hot, this planet isn't quite hot enough to melt rock. Despite the fact that it orbits its star relatively closely, the star itself is cooler than our Sun. As a result, the planet isn't quite as fiery as it could be. LHS 3844b takes only 11 hours to orbit its star. It was discovered in 2019 and is just a little further away than 55 Cancri E at 49 light-years. With a radius that is 1.3 times that of Earth and a mass that is 2.25 times that of Earth, it is closer to Earth in size and mass. But according to Spitzer observations, it hardly has any atmosphere. Webb will explore the planet's rocky surface using spectroscopy. This will reveal to astronomers what the surface is made of, according to Laura Kreidberg at the Max Planck Institute for Astronomy. It turns out that different types of rock have different spectra. You can see with your eyes that granite is lighter in color than basalt. There are similar differences in the infrared light that rocks give off. Furthermore, Kreidberg's team will employ MIRI to investigate the thermal emission spectra of LHS 3844b's day side. The spectra will then be matched to spectra of known rocks like basalt and granite. If the planet is found to be volcanically active, the spectra may reveal trace amounts of volcanic gases. The study of 55 Cancri E and LHS 3844b will provide important information on rocky super-Earth planets. It will inform us about other similar worlds, possibly like the early Earth, when they are still hotter in their initial stages of formation. These findings can then be generalized to other rocky planets, particularly those similar in size to Earth. TRAPPIST-1's 7 worlds are a prime example, which Webb will also be observing. All 7 planets are around the same size as Earth, and some of them may have considerable amounts of water. Bottom line, 55 Cancri E and LHS 3844b will be 2 of the Webb telescope's first science targets, both of which are hot, rocky super-Earth worlds within 50 light-years of Earth. The data will help scientists better understand how these types of planets form and evolve, as well as whether any of them could be habitable. Will Webb find another habitable planet in our galaxy? Let us know what you think in the comments section. If you enjoyed the video, please consider subscribing to the channel.